Okay, let's create the schematic for this circuit. So it's an electronic water. You can see here the electrodes have to be kept here. So for to design a PCB for this, we need to over this. Okay, 2-bit connector is required, and a 2-bit connector required to the AC input, or connector for the AC, or header block with the 2 line, and also the motor board, another 2 wire, and a battery connector. So 1, 2, 3, and 4 types of connectors required, and base and other passive components, and one active component here is SK100 transistor, and it has a relay. You can see a relay which is a 6-volt relay here, and I will show you what type of relay that you need to use. Okay, some of the things that you already discussed. So let me begin with this. So first, add the 5-5 timer. So use this selector, click here, and let put the so 555. So this we have created in the last class, actually 555 timer. So I'm going to place that. So I need these timers. I'm going to copy this, duplicate, and I need one more 5-5 timer. I'll place one more here. Okay. So before you make the selections, let's make the grid selection. That is actually required. So 10 more enough. So let me turn on this. The V. Okay. And let me zoom in. So I'm going to zoom in now. Okay, fine. So you need component side by. Okay, so this is my number 4. And then I need to have the 7404 here. So I will place one more component. Okay, I will place one more component, that is 7404. So click here, you select the component 7404. Okay, and to that, so it's an inverter, actually 7404 is an inverter. We'll place that, and I need a diode also. So I need a diode here. Diode number is it is 1N4148. Okay, so is the diode, that is 1N448. Okay, so 1N4148 is here. So this is the diode. That is actually the package which is used. Okay, so let me choose that diode over here. And what else I need? So let me also put the resistors. Other components I'll simply duplicating it after I add it. Okay, so I need here. So you can see the R resistor which is generated. I choose that and just press R, and you can just reorient the values. Okay. So then what else I need? So I needed R here also. Here I need a potentiometer here. You can see a variable pot I need. So that also I need to set. So that is actually potentiometer pot. So R pot is here. You see potentiometer. This is my R pot. So I'll use this R pot over here. replace it somewhere. So I need a capacitor here, both ceramic. So let me select that also. Choose here, add capacitor here. Click over here and set. So here, you, as I mentioned, polarized, non-polarized. So here you can see here, this is unpolarized. You don't have a plus minus, whereas polarized has a plus minus. So both will select first polarized, and I'll place it here. Then I'll select one more non-polarized. So just again capacitor and unpolarized also. So you place it here. So just look at the circuit again. So we placed two types of capacitors and resistors and diode, and then transistor we need, that is SK100. So I'll place a transistor here whose part number is SK100. Just search here SK100. SK100. SK100 I don't have here. So you can find CK100, or you can just use it. Okay. Just better find transistor. So transistor, find it over here. Okay, transistor is here. Okay, BJT. In that BJT, what type of transistors we are looking for? We need to tell. So I think BC107, we don't have SK series is equivalent to BC, which is a PNP transistor actually. As I mentioned in the component identification, there are NPN and PNP transistors. So what I will do is I will select a PNP transistor. Okay, so let me select a PNP transistor. ABC SK100 is not there. Okay, anyway, we don't have SK100. SK100 we don't have. Okay, fine. So what we do is we select PNP transistors. So here it is. I suggest you to choose BCX51. Okay, BCX51. This series, BCX51 series transistor here, which is a PNP transistor with the 1 ampere current rating, it is mentioned. So we can use that. Otherwise, we can also go for some alternative. So let me use this. Okay. We'll use this transistor BCX51. BCX we will use. Okay, package we'll see later. So BCX51 is a transistor we are going to use, and then we will see what type of relay to use. So we will use the relay now. Click over here, select the relay. Okay, just search here relay. So you get here relay. I suggest you to use the relay of okay, how do you find this? I'm just going to Google it. Okay, so let me tell you how to just here as sugar cube relay. Okay, sugar relay. Okay, you search here sugar cube relay on the Google. So you will get the Jamaco. Okay, G5LE. That is the. So I'm going to show you this data sheet once, so we can understand how this has to be used. So of this way, what I'm going to show here. So this is from the Jamaco company, which produces sugar cube. I'm going to show you that. So just look at this, say Jamaco, and you see how it looks. It's similar to one which I have actually showed. So this is actually a sugar cube relay with the rating of 10 amperes. So what I need to do is I need to go to the last. You see, okay, this is actually the footprint. That is actually we are going to use it in our relay. Okay, so the part number here is what they have specified as the part number is G5LE. So G5LE. So what I will do is I will search here. So G5LE. Can you see this? G5LE, if I search, I will get this. Omron G5LE. So this is the relay that I need to use. So say OK to this. So this is the relay. G5LE is the relay to be used. Okay. So that I will. Then rest all the components I need to keep duplicating all the component in the number what I need to keep on duplicating it. That's it. So let me begin with this. So I have added almost all the component. So let me start looking onto this. So here is the schematic symbol. I need to now do the connection. Before that, I will find out what else is left out. So I think this I can add it later as a connector. I need not have to add it now. Okay. So I need to add a resistor here and one more already there and one more resistors I need. So I will duplicate the resistor. Duplicate. Place it here. Press R. You can rotate the symbol. Then I need this capacitor. Go back here. 470 and three capacitors I need. In that, two are polarized, one non-polarized. Two polarized, this one. Right click, duplicate, press here. So right click, duplicate, and once again here, then again okay. So right click, duplicate, okay, and now it is done. So and one non-polarized, duplicate, one more here. Fine. Then I have to have resistors. So I need two resistors here. I need two resistors there. So click over here, duplicate, place it here, duplicate, click over here, duplicate, and press. So that's it. So place the component as what is required here. I think, and I need to have one more inverter. This is actually a diode. I need to have one more diode here. Duplicate and okay. So right click over here, duplicate and move around. Press R so that you can reorient the components. So I have placed all the components. I think nothing is left. Majority of the components are placed except that I will tell you later. Okay. So we placed capacitors, we placed this resistors and this pot and also. Now let's do connections. So let's begin with the connection here. So and give the values to all these. Okay, and okay, pin number 1 and 5. 1 is directive, 5 is here, which is non-polarized. So this will move to this side. Okay. So place the component very well first. Position it well and so that you can actually connect it a better way. And again these two components are supposed to be together. Okay, here together two non-polarized capacitors, and again pin number 5 here, and I will connect this. Okay, fine. So placement is done, and I need to have that pod also here. Okay, fine. Begin with the connection now. So I'm going to zoom this area. Okay. Now how do you connect? Take a wire here, and okay, I think there is a problem with this. Yeah, there is a problem. Delete. There are multiple components, that's why it is not shown. Okay, so I think yeah, here also some multiple values there. Delete that. Okay, fine. Fine. So now let's do the connections one by one. So if you need to make a slight movement, please make that. Okay. So let me connect it using the wire. So I will connect this point. Sorry, it's not connected. So let's zoom in. Then take a wire, connect it. Yes, that connected. Then take this wire, connect it over here. Take this wire, connect it over here. Okay, Control Z. Yeah, it's connected. So zoom out. Now I need this resistors to be connected over here. Yes, it is connected. So, and I need to connect this resistor. Zoom in. Okay, I need to connect this to here. So just connect it and place it over here. So okay, it's not connected properly. Just zoom in here. Select this. Yes, perfect. So it's connected now. So again zoom out and look at that circuit here once again. Alt tab. You see here it's supposed to go to a connector actually probe, and we will use a simple connector there. Okay, we will provide a connector here. So use the symbol and place a connector. So this is actually so RM. Okay, no, we don't get a connector of. Okay, we will have a screw terminal connector. So we will have the screw terminal connector here. So this is single bit connector. This is actually two terminal connector. Okay, we can place this 2-bit connector here. So place okay over here. Any 2-bit connector is okay. We will not worry about the footprint right now. So we will place component. Later I can suggest you what is the footprint to be used for this. So we can simply rotate this component. So rotate it. Okay. So the one terminal will go here and it comes to connect it to this. So let me zoom in once. Okay. So carefully choose the point, then connect it. So connect this. Yes. So it's connected. Other terminal, let's connect it to the ground. According to the circuit diagram here, you can see here in the circuit diagram, one is connected to the soil which you are going to give a connector. So other is actually ground. All these are actually ground. So we can have a ground connection there. So provide ground connection here. So use the symbol and provide the power and provide a ground. Yes. We can provide a ground symbol here. So this is connected to the ground. Okay. So I connected this to the ground. So now this part of the circuit is complete. So let's connect to this now, this side. So what and all we need to do. So pin number 6 and if you look at the circuit, pin number 6 and 7 is short. 2 is supposed to be given to the inverter. From here to the port. Okay. So we will do that connection. So in the port, if you see, zoom in. So I need to short either of this 1 or 2 and 1 or 3 depending on what we need. Okay, so we will short. I will short these two. If you look at the circuit, you see here it is shorted. Okay, then it goes to 7. So 6 and 7 I need to make it short. Okay, so let's go here. So let's short pin number 6 and 7. Pin number 6 and 7 should be shorted. So I connected pin number 6 and 7 should be shorted. Then pin number 2 should be given to this. Okay, I connected it here. So pin number 2 should be given to the output of this. And we have here a capacitor C1 which should be connected to pin number 6. So there is a capacitor here which should be connected to pin number 6. Okay, it's connected. Then all this capacitor I need to ground it. So here pin number 5 should be connected again with the capacitors. Oh sorry, it's not connected. Okay, so let's connect it here. Oh sorry, zoom in. Yeah, it's connected. Out. Now I need to connect, okay, pin number 7. Okay, I can make it little more better, but it's okay. Connect it over here. It's connected. So this part of the connection is over. Now next is with number 4 and 8 should be given to VCC. I'll connect it. Okay, other one is not properly connected. Yes, connected. Then this will go to VCC. VCC over here. So we will have a connection from here till here. Okay, and this also we will connect it to here. So we'll make this little down, and I'm going to connect this to. Okay, not selected properly. Okay, so this is connected. Again, look at the schematic once again. So this part of the circuit is over. 4 and 8 we connected to VCT. 1 and 5 should be connected to the ground. So one side we complete it. 1 and 5 should be connected. So I'll put a ground here. Yeah, that's so here. I'm going to place a ground which is already here. Okay, so zoom in to this ground here. I think there are multiple values here. Okay. Okay, I guess here also I have multiple pins. Okay, fine. That's how it is connected. Okay. So zoom out. Now again take this and connect all these wires, and it's not connected properly here. And okay, so that's also fine. Here also it is to be connected. So all these points are connected to ground here, and that's completes the circuit. Pin number 1 directly connects to the ground. So I'll use this here again, this is pin number 1 directly connects to the ground. So that's complete. So look at the circuit again. So I'm going to again build this complete this section. So I'm going to make these two values. So let me put the values later. What is required to complete this? Let me complete this connection first. Then I will assign the values to. It's not proper. Okay. Zoom in to make the connection. Okay, done. So zoom out. Again here also 6 and 7 is short. 6 and 7 is. I need to make the connection here. Zoom in. 6 should be short. Sorry. Okay. So zoom out. Now let's look at the circuit here. Sorry, pin number 2 and 6 should be short. Okay, that's in the monostable. 6 should be short, not 6 and 7. So I will just modify that. I need to delete that. Okay, pin number 2 and 6 should be short. Okay, use a wire here again. Pin number 2. Sorry. Connected. And look at the circuit here. So between 6 and 2 shorted, the resistor other end will go to 7. And this resistor down. So okay, this value I will bring it down. Okay. So what basically happens here is I need to connect this point to here. Not connected. Zoom in properly. Then choose a point and connect. Okay. Zoom out. And this will go to here. Connected. Okay. And this capacitor, that is actually both the capacitors are there. This capacitor, so I'm just going to move this capacitor a bit. Oh, okay, what happens? Control Z. Okay, fine. I'll do that connection later. So F1. Z, I'm going to connect this capacitor to this point. Okay, then this supposed to be the capacitor connected to the power, directly to the power, so I will connect it here. I think this we can have it later also, this connection. Okay, it's connected straight away to the VCC. Fine. And if you see here, pin number 3 is connected to pin number 2. I need to refer to the circuit again. Pin number 3 is connected to this point. Okay, the junction. So I will do that, and I need to complete the connection, which is properly connected here. Okay. Fine. Other end here. Sorry for this lines. Okay, I can. Okay, fine. So yeah, pin number 3 should be connected to pin number 2 here. So let me connect that. Done. So this part of the circuit is done. So here we have missed some connections. So let me solve this. Okay, so you connection from here. It's not properly. Number 7. Fine. So this is complete. Yeah. Again, this part of the circuit is left now. We will continue with that. Okay, again the pin number 4 and 8 here. Pin number 4 and 8 should be shorted, and should be connected to again VCC here, and this resistor and this will bring down both of these components somewhere here. Fine. And we will connect this also diode to the VCC here. And this is a PNP transistors. Now you see here this, the emitter will come on the other side. The arrow is supposed to be flipped actually. So right click and change the orientation. That is mirror around the x-axis. Okay. So move this component, and this is directly driven with pin number 3. Okay. And I this end of the circuit should be shorted with pin number 2, and pin number 3 okay, pin number 3 should be connected to this point. Pin number 3 should be connected over here, and pin number 1, look at the circuit once if you need anything. Yeah, this is the circuit. Okay, This point is connected to the relay by shorting this diode with this coil and connected to the VCC. The other end should be grounded. So do that connection. And other end should be grounded. So we will do that connection again. Yes, it's connected, completed. The other end should be connected to pin number 5 should be connected to the VCC. That's over here. Okay, now what is left is this is common terminal. This is normally closed and this is normally open. So I need to give a connector again here. I need to give a connector here. So let me insert the components, or I can actually duplicate this what we have here. Okay, whatever I have here, I can duplicate this connector. So you simply duplicate and move around here. One will be for the VCC, and another I'm going to use it for duplicate again. Okay, here, and one more connector. Okay, duplicate. Okay, so let me move that, duplicate, and just move it. Okay, so three types of connectors I will connect it here, so that will complete the connections. So do this. Okay, I think we can now complete the connection within some 5 minutes. So what is left is actually we need to connect this. So this part I will tell you later. Now how to edit the values, click on this, keep on editing the values on this. So that is actually 4.7k and 8.2k. Okay, this is 4.7, 8.2 value. So you know the way to edit. So we will simply start editing this value. So click on this. The value is 4.7k. Sorry, Control Z, 4.7k. Okay, value, and this will be E. This is 8.k, and this part here is 820k. So another is 820k. So this R part, edit 820k, and this capacitor, if you see, 470 and 0.01. So this is edit 70 UF, and this one edit 0.01 microfarad, and this one again 100 microfarad and 10 microfarad. So edit 100 microfarad and one is 10 microfarad, and this one is 0.01 microfarad farad. And this value R, if you look at the circuit, it is 27k and 27k. So both are 27k. So this one edit 27k. This one also edit 27k. That's it. So okay, this is how the connection is to be made. and this is how the components and things are connected. So I'll continue with I want after connecting this. Okay, so you need to name it as one is VCC and ground, and this should be, just look at the circuit and the connection. So that's it for the today's class. Thank you.